We have found the domain of a function by looking at its graph, but now we're going to be able to find the domain of a function algebraically. The good news is that most functions have an implied domain of all real numbers, because most of our functions that we look at, like lines and parabolas and things that we will get into in the course, are polynomial functions. Look at what they are. They're functions, they don't have any fractions, they just have powers, and all of that would be all real numbers. However, there's another type of function that we will be graphing and analyzing, and they're called rational functions. A rational function is a ratio of two polynomial functions. Ratio meaning a fraction. And so since there's a fraction, there's a denominator. And we have to remember that you can never divide by 0 because it's undefined. So in order to determine the domain of that rational function, we have to look at that denominator. So we're going to set that denominator equal to 0 and solve, and those are the values that are not acceptable, because if the denominator equals to 0, then we have something that's undefined, which we don't want to happen. Alright, so we're going to take the denominator, we're going to set it equal to 0. How do I solve that? It's a quadratic, so I'm going to factor that. I think 8 times 5 works nicely. Set each factor equal to 0. And let's just stop right there. If this equals to 0, that means that the denominator would equal to 0, and then it would be undefined. Same thing for that. So that gives us the values of 8 and negative 5. If you put in an 8 for x, you're going to get 1 over 0. If you put in negative 5 for x, you're going to get 1 over 0, and that is undefined. So our domain is all real numbers except 8 and negative 5. I'm actually going to write that down. All reals except 8 and negative 5. So how could I write that as an answer? You know what? I'm fine with this. You could also write it as not equals to 8 and negative 5. That implies everything else. But if you wanted to do it in interval notation, that's a little bit trickier. You'd have to go from negative infinity to negative 5, negative 5 to 8, and then 8 to infinity. So it can be done, it's just a little messy. Let's look at this example. So now we have two rational expressions. So we're going to look at this denominator and this denominator. So let's look at that one. Can that ever equal to 0? Think about it. When you square a number, you're going to get something positive. You're going to add 9 to it. That's always greater than 0. The only way you could add something to positive 9 is something negative to get it equal to 0. So this never equals 0. So we don't have to worry about this. This is all reals. But what about x squared minus 9? Can that equal to 0? Yes, it can. So we could factor that, or we could just solve for x. I'm just going to solve for x by adding 9 to both sides. Take the square root, and you get plus or minus 3. So that's the thing you have to be careful if you're not going to factor it by the difference of two squares. You've got to make sure you have that plus or minus sign. And so these are the values that would make this denominator 0. So we would have all reals except 3 and negative 3. And again, you could write it like this. You could go back and write it in interval notation. Now this next example, we've got fractions on top of fractions. A little bit more difficult. So let's take this part, because x minus 2, if I let that equal to 0, that means x cannot be 2, because if it was, it would make that fraction be undefined. But what about the whole thing, that big O fraction? Well, so now I have to look at 5 over x minus 2 minus 3 and solve for x. Ugh. Well, let's make that into one big fraction, so I'm going to find a common denominator. So that means I have to multiply this part by x minus 2 and this part by x minus 2. So all over x minus 2, we would have 5 minus 3x plus 6. Remember, distributes. We'd have negative 3x plus 11 over x minus 2. When is that going to equal to 0? Well, we know if I put in 2 for x, then it's undefined. But when is this whole thing? Well, one way you could do it is cross multiply. So if I cross multiply, didn't leave myself quite much room, so I'd have 1 times negative 3x plus 11, and I'd have 0 times x minus 2, which is 0. So solving for x, I get 11/3. That means if you put in 11/3 for x, then the whole thing would also be undefined. So we have all reals except 2 and 11/3. A little bit trickier, so be careful. The other type of functions that we may encounter are radical functions. What are these? This is a function that's underneath some kind of radical. Our most common radical sign is a square root. Remember, when you're taking the even root, most of the time it's a square root. If you take the square root of a negative number, the answer is imaginary. So how are we going to get the domain of a radical function? And again, we're looking at even, odd. That's a whole different story. So let's look at even radicals, mostly our square roots. So let's see, what does it say? It says to determine the domain of a radical function, set the radicand, that's the part underneath the radical, greater than or equal to 0 and solve, and this is going to be our domain. So if I set x plus 2 greater than or equal to 0, let's try to understand that. What kind of numbers are greater than 0? Positive. I can take the square root of positive numbers. Those are real. If it equals to 0, the square root of 0 is 0, and that's okay. But if I had the square root of negative, then that is not real, and that's why I'd have to throw those out. So as long as we restrict it to something greater than or equal to 0, we're okay. So this is pretty easy. So all numbers greater than or equal to negative 2. If I wanted to write that in interval notation, that's from negative 2 to infinity. For those of you who need a little bit more visual, it'd be negative 2 and greater. So let's do the same thing here. We're going to take 8 minus 6x, solve. So if I subtract 8, now this is where you have to be careful. I'm dividing by a negative. What happens? You flip that inequality and reduce. So our domain is x is less than or equal to 4/3. And again, so if I had 4/3, that would be to the left. And in interval notation, that would be from negative infinity to 4/3 bracket. So those are your basic radical functions, square roots. Let's get a little bit trickier on these next two examples. Number 7 is a combination, so we have to look at both. We have to look at x minus 3 and x plus 5. Both of those, both have to be true. They both have to be greater than or equal to 0. So we have x is greater than 3, adding 3, and x is greater than or equal to negative 5. This answer is not acceptable. Not finished. You have to combine those, and I think the easiest way is to look at a number line. So we have negative 5, positive 3. So for x is greater than or equal to 3 are all of these numbers. for x is greater than or equal to -5 are all of these numbers. Go back to, you have to have both are true. So where on the number line are both colored in? All of that. So your final answer is x is greater than or equal to 3. As long as you put all numbers greater than or equal to 3 in both of those radicals, you're going to be okay as far as that domain. And so we would have from 3 to infinity. Number 8 combines a radical with a rational. We have a fraction, so we have to use both of our rules. We have to make sure that what's underneath the radical is greater than or equal to 0, but we have to make sure that we don't divide by 0. In fact, I'm going to go ahead and say not equals. I think that might be a little bit easier. So we would solve for x, solve for x. Again, not finished. Let's look at those on that number line. So we have 3 and we have 6. So greater than or equal to 3, that's all of those. But then not equal to 6. That means I've got to not have 6 there. There's a hole. So how am I going to write that answer? From 3 to 6, but not equals to 6 with that parenthesis, and then 6 to infinity. That's your final answer. That's what I'm looking for on the test. So let's practice that one more time, or better yet, pause the video and you practice it and then come back. So again, we have that radical and we have the denominator. So x cannot be -4, and let's see, I subtract 2 and divide by -5, so I have to flip that inequality. So I know there needs to be a hole there. This is less than or equal to, so I'm coming along here. I have to skip over that, so instead of erasing, I just put that hole to begin with. So I've got from -infinity to -4, not including, and then that bracket. Again, that's your final answer. That's what I'm looking for on the test.